comparison operating system structure between Mac OS and Windows. It was developed and is owned by Microsoft Incorporation. Mac OS, it was developed and is owned by Apple Incorporation. For Windows, most PCs come with the latest Microsoft Windows. For Mac OS, Mac computers are pre-installed with the latest version of Mac OS. Windows, it is designed for PC of all companies. Mac OS, it is specifically designed for Apple Mac computers. For Windows, current stable version is Windows 11. For Mac OS, current stable version is Mac 12.0.1 Monterey. Windows, it is for workstation, personal computers, media centers, tablets, and embedded system. Mac OS, it targets system type if workstation, personal computers, and embedded system. Windows computer architectures supported by Windows are IA32, x86-94, IA64, ARM, Alpha, MIPS, and PowerPC. For Mac OS, computer architectures supported are x86-64, 10.4.7 present, IA32, 10.4.4.10 or until 10.6.8, and PowerPC 10.0 until 10.5.8. For Windows, file system supported are NTFS, FAT, ISO 9660, UDF, HFS+, FATX, and HFS. For Mac OS, file system supported are HFS+, APFS, HFS, UFS, AFP, ISO 9668, FAT, UDF, NFS, SMBFS, NTFS, FTP, WebDAV, and ZFS. For Windows, kernel type is hybrid with module here. For Mac OS, kernel type is hybrid with modules here also. For Windows, package management is MSI or custom installer. For Mac OS, package management is Mac OS installer. For Windows, update management is Windows Update. For Mac OS, update management is software update. And lastly, for Windows, the native API are Win32 and NT API. For Mac OS, the native API are Carbon, Cocoa, Java, and BSD POSIX.
Next, I'm going to explain the comparisons of process scheduling between Mac and Windows operating system. There are 8 comparisons stated here. The first one is Mac operating system use cooperative scheduling for threads, where one process controls multiple cooperative threads and also provide preemptive scheduling for multi-processing tasks. For Windows operating system, it uses a non-preemptive scheduler, meaning that it did not interrupt program. It relied on the program to end or tell the operating system that it didn't need the processor so that it could move on to another process. The second comparison is Mac operating system uses a multi-level feedback queue with 4 priority bands for threads, which is the first one is normal, between 0 to 51 priority. The second one is system high priority, between 52 to 79 priority. The third one is kernel mode only, between 80 to 95 priority. And the fourth one is real-time thread, between 96 to 127 priority. For Windows operating system, it also uses a multi-level feedback queue with 32 priority levels that are defined 0 through 31 with priority 0 through 15 being normal priorities, 16 through 31 being soft real-time priorities requiring privilege to assign. For the third comparison, Mac operating system has two scheduling approach, which is traditional and scheduling with CPU core affinity. For Windows operating system also have two scheduling classes, but the class is real-time or fixed classes with priority 16 to 31, and the second class is dynamic classes with priority 1 to 15. For the fourth comparison, some aspect of threads priority in Mac operating system can be controlled from user space using the POSIX thread priority API. You can use BSTP thread API to change basic policy and importance. You can use Mac RPC calls to change a task importance, and also you can use RPC calls to change the scheduling policy to move a thread into a different scheduling bank. For Windows operating system, the Windows API function set thread priority set the priority value for a specific thread. This value, together with the priority class of the thread process, determine the thread-based priority level. Windows will dynamically adjust priorities for non-real-time threads. For the fifth comparison, scheduling time slices in Mac operating system, each process gets a small unit of CPU time quantum, usually 10 to 100 milliseconds. The process is preempted and added to the end of the ready. Scheduling in Windows, the thread time slice or quantum is 10 to 120 milliseconds, when quanta can vary, has one of two values. Next, real-time threads that are heavily compute-bound are given lower priority to help minimize response time for interactive tasks so that high-priority compute-bound threads cannot monopolize the system and prevent starvation for the Mac operating system. For Windows operating system, real-time threads can starve important system services such as csrss.exe file. The increased base priority privilege is required to elevate a thread priority into a real-time range. For the seventh comparison, in Mac operating system, CPU partitioning is possible. Meanwhile, in Windows Vista SP1, CPU partitioning is not possible. And lastly, scheduler in Mac operating system, load balancing is possible. Meanwhile, scheduler load balancing in Windows operating system is not possible.
Firstly, what method that Windows OS using to handle the deadlock? In the kernel, they have spinlock. What is spinlock? Spinlock is a locking system mechanism. It allows a thread to acquire it to simply wait in loop until the lock is available. Thread waits in a loop or spin until the lock is available. Spinlock is held for a short period of time. Spinlock are useful in multiprocessor systems. After that, rollback is one of the deadlock detection and recovery. What is rollback and how rollback function in deadlock handling? We must determine what should be done with the process from which resources are preempted. One simple idea is total rollback. That means abort the process and restart it. Recovery through rollback is checkpoint a process periodically save state. State should contain memory, image, and status of resources. Start the process if it is found deadlocked with the state of the last checkpoint. But since the used checkpoint is lost, process has to wait to reacquire the resources.
Next is the comparison between Mac and Windows file system. Firstly, Mac file system is case sensitive, which allows you to name files of the same name but different letter cases, while Windows does not allow you to name files of the same name even though with different letter cases. Next, Mac file system has encrypted service which data stored on the drive can be encrypted, while Windows must encrypt files using encrypted file system aka EFS, which is a file encryption service offered in Windows 10 and all previous versions of Windows. Number 3. Mac OS utility software to manage data is called Disk Utility Tool. It is said that Mac OS Disk Utility Tool is easier than Windows Disk Management Tool, while Windows utility software to manage data is called Disk Management Tool. Both of them are used to manage data on disk by performing various functions on it, such as partitioning devices, manage drives, disk checking, disk formatting, and many more. Number 4. The file system Apple uses is called the Apple File System, or known as APFS. APFS contains a filing technique called copy on write, or known as COW, which ensures maximum security and heavy compression. APFS also uses superblocks to store certain elements of data to ensure speed and efficiency. File system that Microsoft has implemented is called New Technology File System, or known as NTFS. Microsoft has attempted to set NTFS as the standard for file handling across devices such as external hard drives and USB flash drive. Lastly, the file structure of Mac is commonly known as Mac OS X. If we dig into Mac's hard disk through the Finder, there will be many directories. There is no going into a partition to find a folder, to find another folder buried within the folder that contains another folder like there is on Windows. While Windows follows a directory structure to store the different kinds of files of the user, it has logical drives and cabinet drawers. It also has folders. Some common folders like documents, pictures, music, videos, and downloads. All these files can be stored in these folders and new folders can be created.